all the children of a 12th standard, senior secondary level, who are all in the pursuit of excellence to achieve, to accomplish centum in the board examination. Today we will start with the electrostatics. First topic being electric charge. Let us have the electric charge in today's class. Children, what is the ultimate of any matter? What do you mean by ultimate? The smallest of the small. If you take any matter, do you think ultimately we land at an atom? No. An atom is not ultimate of any matter because an atom can further be split up. So obviously electron, proton, neutrons are ultimate of any matter because they are the smallest of the small in the entire universe. So electron, proton, neutron, these are all called fundamental particles, otherwise called elementary particles, otherwise called primary particles. And electron is elementary in nature. All the matters around us are building blocks of electrons. How these electrons, protons, otherwise called charged particles, and a neutron is uncharged, you know. How these charges can be produced? Is it possible to produce? Let us see later on. Now, this chapter is called electrostatics or static electricity because in this chapter we are going to deal with the charges at rest. We are going to talk about only stationary charges. The next successive chapter we will be dealing with the charges in motion, which is called current electricity. But here we are going to talk about the stationary charges. How these stationary charges can be generated. Simplest process because it can be produced by just rubbing. It is called frictional electricity. Let us take a glass rod and let us rub it with the silk cloth. When a glass rod is rubbed with the silk cloth, before rubbing, glass rod was neutral in atomic state. On the other hand, the silk cloth was also in atomic state neutral. But at the time of rubbing, one loses electron, another gains an electron. By losing an electron, the glass rod becomes positively charged. See, loss of electron makes it positive. After gaining an electron, the silk cloth becomes negatively charged. This is how we can generate charges in these bodies. See, one hand I am holding glass rod, another hand I am holding silk cloth, both are charged. You know what will happen when they are made to be in contact with each other? When they are in contact, immediately neutralization will take place. No more charge it may carry. Similarly, let us take a demonite rod and let us rub it against the fur, nothing but animal skin. So when demonite rod is rubbed with the fur, demonite becomes negatively charged and the fur becomes positive. How it has become negatively charged? Obviously by gaining an electron. An electron is added to the ebonite rod. So after gaining an electron, ebonite rod becomes negatively charged and on the other hand, the fur, the animal skin would become positively charged because of loss of electron. So this is how we can produce charge by rubbing. There are other methods, charging by conduction, charging by induction. All these chapters we are going to deal in the following chapters. Now this elementary charge I told, that is fundamental, which is prevalent in all the matters around us in the entire universe. Let us go in details. Now see the board. My dear children, let us talk about electron first. Mass of an electron, it is very small. See how small it is, 9.109 10 power minus 31 kilogram. See how small it is. But what about proton, which is located inside the nucleus of an atom? It is just greater. How much it is? 1.672 10 to minus 27 kilogram. So proton is heavier, massive compared with the electron. How greater it is? See the relation. Mass of a proton is 1836 times greater than that of mass of an electron. What about a neutron? In lower class you should have studied more or less it is equal in mass with that of a proton. But accurately to say, mass of a neutron is slightly greater than that of a proton. See how it varies. It is 1.674 10 to the minus 27 kilogram. I told about elementary charge. Electron is an elementary, proton is also an elementary. Both are having same magnitude of charge. Only polarity differs. Electron is negative, whereas proton is positive. How much is the magnitude of each charge? It is called unit charge. So fundamentally unit charge is denoted by the symbol small e. Remember children, E may mean electron in nuclear physics chapter, but in this chapter E is the general notation standing for both electron and proton because it denotes the unit charge. The value of unit charge is given by 1.6029 10 to the minus 19 coulomb. Corrected to one decimal because second decimal is 0 after all. So let us round it off as 1.6 10 to the minus 19 coulomb. Now let us talk about some of the interesting theories behind the electric charges. First comes quantization theory, otherwise called discrete nature of charges, electric charges. See, quantize means where the charges can be counted. Counting up of the charges is simply possible. So we call charges can be quantized. Example. In a charged body, it may contain n number of charges, where n is an integer, n is a whole number. Can n be a fractional number? Never. Can I tell there are 33 students in the class or 33.5 students in the class? Never it is 33.5. It may be 33 or 34 because number of students in a class will be a whole number. Definitely it is an integer. Similarly here, number of charges in a body, it will be an integer. So Q is equal to LE. E is unit charge, Q is net charge, resultant charge, effective charge, total charge. So the net charge Q equal to LE. We can expand this formula beautifully in a statement form. Net charge of a body is equal to integral multiples of unit charge. I repeat, integral multiples of unit charge is equal to net charge. All the bodies have got only integral multiples of unit charge only. Next comes additive nature of charges. See, the net charge of a body is equal to algebraic sum of individual charges distributed throughout the body. Suppose I am having this rod which is charged. Throughout the body there are number of charges with a different polarity. +4, -3. Here there is +4 coulomb. Here there is -3 coulomb. And they are distributed throughout the surface. What is the algebraic sum of both? So +4 -3 is +1. So the net charge is equal to algebraic sum of individual charges throughout the body, distributed throughout the body. So that is what we mean by additive nature of charge, where the net charge is equal to algebraic sum of individual charges distributed throughout the body. Next, another very important theory, law of conservation of charges. There are so many laws of conservations. You would have studied in lower class: conservation of mass, conservation of momentum, conservation of energy, conservation of matter. Similarly, here comes law of conservation of charges. How we can define it? According to this law, in an isolated system, the net charge always remains the same. In an isolated system, net charge of a body always remains unaltered, remains the same. And this charge can neither be created nor be destroyed. I told you an example in the beginning. A glass rod rubbed with the silk cloth, glass rod becomes positive, silk cloth becomes a negative. Did I produce any charge here? Actually, true to speak, truly, I can say here, I have not created any charge. I have not created, I have not produced any charge. So creation is impossible. There is no creation of charge at the time of rubbing. By frictional electricity, which I told already, I didn't produce, I didn't create any charge. Who am I to produce any charge? But what all happening is, charges are separated. Previously, before rubbing, it was neutral. Now it has become positive. On the other hand, the silk cloth become negative. That is why the meaning of law of conservation of charge we can say like this. Creation is impossible, production is impossible, separation alone is possible. So this is what we should understand. This is how we should understand by law of conservation of charge. Let us take another example in nuclear physics. Now this is an equation having nuclei. See, let us have uranium nucleus whose atomic number 92, mass number 238. You know, in radioactivity, it gets decayed. So by the process of decay, uranium 238 would become thorium 234 by giving away an alpha particle. An alpha particle, He24, is nothing but helium nucleus. Two positive charges of helium ion. So by giving away an alpha particle, it becomes thorium. Let us take this example. Here, how we can explain, how we can validate the law of conservation of charge is simple. So you know, in nuclear physics, atomic number, it has got a beautiful definition. Number of charges is called atomic number. Number of charges is called atomic number. So here there are 92 charges in the reactant side. In the product side, thorium 90, alpha particle 2, alpha particle charge 2, thorium nucleus charge 90. So in the product side, if you add, you get 92. 90 plus 92, 92 balanced. Thus we can prove the total charge always remains the same. In addition to this consideration of charge, you can understand by mass also, which will be useful in your chemistry. See, this is about the subscript. What will happen when you add a superscript in the product side 234 plus 4? Is it not telling about mass? So mass of the product is equal to mass of the reactant. Is it not law of conservation of mass in your chemistry lesson? Yes. So same is the equation which stands good for both the law of conservation of charge and mass. Now I told unit of charge is coulomb. Actually, suppose this body carries a charge of 1 coulomb. What does it mean? Let us consider it as a problem. Now, look here, my dear children. Say, unit of charge is 1 coulomb. Suppose there is a question. How many electrons constitute minus 1 coulomb of charge? Otherwise, I can say, how many protons are present in plus 1 coulomb of charge? In general, I take it as 1 coulomb. Because I told elementary charge represent both electron and proton. So, how many elementary charges are present in 1 coulomb? Let us consider it as an example, numerical problem. I told you Q equal to Ne formula. From this Q equal to Ne, we have N equal to Q by E. Let us carry out the problem. Q is 1 coulomb, I told, net charge is 1 coulomb. E is 1.6 10 power minus 19, which is charge of an electron or proton. If you simplify, you get 6.25 10 power 80. Will you give any unit for this? No. How you can give unit for number, mere number? So there is no unit. So what does it mean? When I say this carries 1 coulomb of charge, it has got 6.25 10 by 18 elementary charges. 6.25 10 by 18 electrons are present in minus 1 coulomb of charge. Or 6.25 10 by 18 protons are present in plus 1 coulomb of charge. My dear children, now let us have some practical application in our real life. Now switch over to slide now. Now see the board. It is just like a problem. 2 point charges Q1 and Q2 are placed close to each other in air. What is the natural force between them when? Subdivision 1, Q1 into Q2 is less than 1. Subdivision 2, Q1 into Q2 is greater than 1. Now, how we can solve? Because Q1 Q2 is less than 1, don't you think it is negative? So, product becomes negative. If product becomes negative, it means Q1 Q2 will have opposite charges. Opposite charge will attract or repel? Attract. So, have a statement like this in your mind, my dear children. Always attractive force is negative. Why? Attractive force, it means both the charges should have opposite side, unlike charges. Positive, negative, when you multiply, is it not negative? It means less than 1. Similarly, second subdivision greater than 1. Q1 Q2 is greater than 1. Q1 Q2 greater than 1 means it is positive. So, product positive means both will have same sign, minus minus or plus plus. So, have a statement like this in your mind. Always repulsive force is positive. Attractive force is negative. Remember this as a formula, my dear children. Let us go to another example. You would have seen vehicles carrying inflammable materials usually have metallic ropes touching the ground during its journey. Why? See the answer. The charge produced due to friction will flow to the ground through the metallic rope. Through those ropes alone, the charge accumulated in the vehicle will get transferred to the earth. You know one thing, earth is otherwise called zero potential. Whatever charge you give, it will take and remain at the zero potential only. Next application. Tires of aeroplane. Tires of aircraft are made up of special conducting rubber. Why? Here is the answer. When the aircraft moves in air due to friction, more and more charges are produced and get accumulated on the body. When it is landing, again due to friction between the tires and the ground, more charges are produced which may cause spark or fire. Since the tires are made up of rubber with the conducting material, all the charges are getting transferred to the earth. Now let us go to last application. Application of electrostatic, attractive and repulsive forces in Xerox photocopier machine. Now have a look at the diagram on the screen. Though this topic or diagram is not meant for your board examination, definitely you are required to know how this electrostatics is applied in real life. Because everywhere we used to come across this machine, so we feel it is mandatory to know about the simple working of this electrostatic machine. Here, see the diagram. Electrostatic charge is given to a cylindrical drum in the Xerox machine by high voltage wire called corona wire. This drum is coated with the photoconductive material. When exposed to light, it starts conducting. When a bright lamp is incident on the original document, the white areas of the original reflect light onto the surface of the photoconductive drum. The areas of the drum which are exposed to light start conducting and therefore discharge it towards the ground. The areas of the drum not exposed to light, black portion of the original document, remains negatively charged. The toner of the machine is positively charged. When it is applied to the drum to develop the image, it is attracted and sticks on to the areas that is negatively charged, black areas. The resulting toner image is transferred from the drum to the paper under print. The toner is melted and bonded to the paper by heat and pressure rollers. This is how the force of attraction between unlike charges and the force of repulsion between like charges and the transfer of charge play the role in the Xerox photocopier machine. My dear children, in today's class we have dealt with electric charges only. Next class we will talk in detail about Coulomb's law. Wish you all the best. Thank you very much.